The sky above you is not empty. It is silent. And those are two very different things. Right now, above the roof over your head, there are more stars in our galaxy than there are seconds in 100,000 years. Our galaxy has been spinning for so long that any single civilization, if it wanted to, could have crossed it from edge to edge many times over before humans ever learned to walk upright. By every model we have, the sky should be crowded. It should be loud. Instead, we point the most sensitive instruments ever built at 1,000 nearby stars, and we hear nothing. Not a whisper. Not once. And nobody can fully explain why. If that gap between what should be and what is makes the back of your neck feel cold, hit that like button and subscribe. Because we are going to climb down into 30 different answers, and each one is worse than the last. Tell me in the comments where in the world you're listening from, and what time it is where you are. Now turn the lights down. We're going under. Let me build you the picture first, the comfortable one, the one that makes the silence feel wrong. Start with the numbers, because the numbers are real, and they are staggering. When astronomers combed through data from NASA's Kepler Space Telescope, they came out with a conclusion so large it barely fits in a sentence. Our galaxy holds at least an estimated 300 million potentially habitable worlds, based on even the most conservative interpretation of the study. That is the floor. That is the number they chose when they deliberately walked to the low end of everything. When their model was applied to current estimates of 4 billion sun-like stars in the galaxy, it suggested there are at minimum 300 million with at least one habitable planet, while the model's average posits that 1 in 2 sun-like stars could have a habitable planet, causing that figure to swell to over 2 billion. Sit with the size of that for a moment. Not the raw digits, but the feeling. Imagine you're standing on a beach at night, and someone tells you that for every grain of sand you can hold in one cupped hand, there is a world out there, roughly Earth's size, at roughly Earth's distance from a star like our Sun, where liquid water could pool on the surface and stay. Now imagine handful after handful, all the way down the shoreline, past where you can see. That is the scale we are working with. And these aren't wild guesses from dreamers. This is the sober output of a crippled space telescope that spent 4 years staring at one small patch of sky and counting shadows. Here's the first detail I want you to file away, because it comes back later, transformed. Kepler could measure a planet's size. It could measure its orbit. It could tell you the world was there, but it could not tell you if anything was living on it. Not a single one. Every one of those hundreds of millions of worlds is, for now, just a shape and a distance. Remember that. It matters more than it sounds. Now add time. Our galaxy is old, almost beyond comprehension. The first stars ignited when the universe was young, and stars like our Sun have been forming and dying for billions of years. Our Sun and our Earth are latecomers. They formed in the last third of cosmic history. Which means that on countless of those other worlds, if life is even a little bit common, the clock started running long before ours did. Some of them had a head start on us of 1 billion years. 2 billion. In some cases, more time than the entire span from the first fish crawling onto land to you sitting there listening to me, repeated over and over. And 1 billion year head start changes everything. Because of one simple, brutal fact about how far a civilization can spread if it decides to. You don't even need faster than light travel. You don't need magic. You need patience and one clever machine. The idea is named for a Hungarian-born mathematician, John von Neumann, who worked out the theory of a machine that can build a copy of itself. Now picture such a machine as a spacecraft. It flies to a nearby star, mines the asteroids there for raw material, and builds 2 copies of itself. Those 2 fly to 2 more stars, and each build 2 more. Then 4, then 8. You already know where this goes, because it's the same math as a rumour spreading through a school, or a single cracked pipe flooding a whole house. It doesn't add, it multiplies. And multiplication, given time, eats everything. The estimates for how long this would take are the part that should unsettle you. Models of directed self-replicating probes demonstrate that a single launch from one star system could explore the entire Milky Way within approximately 10 million years, assuming replication cycles of a few decades and travel speeds far below the speed of light. 10 million years. That sounds enormous. It isn't. A single self-replicating probe, launched once, fills the galaxy in roughly 1 million to 10 million years, and the galaxy is billions of years old, so if any civilization, anywhere, ever built one, we should see it. Let me make that timescale touchable, because 10 million years is not a number the human body understands. Compress the entire age of our galaxy into a single calendar year. Every star, every planet, every eon squeezed into 12 months, January 1st to December 31st. On that calendar, the time it would take one civilization to colonize the whole galaxy with self-replicating probes is less than a single day. Less than one flip of the page. So here is the trap closing. If even one civilization out of hundreds of millions of possible worlds across billions of years ever decided to spread, then the galaxy should already be full. Full of their machines, their signals, their leftovers, their fingerprints on the asteroids. They should be here. They should have been here for ages. They are not. Nobody's here. The inbox is empty, and that emptiness is the whole problem. This is the paradox, and now that you feel the shape of it, you understand why it broke a brilliant man's afternoon. It was the summer of 1950, in the high desert of New Mexico, at the Los Alamos laboratory, where the atomic bomb had been born just a few years earlier. The Soviet Union had recently detonated its first atomic bomb, and the famous National Laboratory was now in the middle of a crash program to build a better one, a magnet for some of the most prominent physicists in the world. 4 of them were walking to lunch at a place called Fuller Lodge. Enrico Fermi was walking with Emil Konopinski, Edward Teller, and Herbert York. And on the way they were talking about reports of flying saucers and whether faster-than-light travel was even possible. Fermi was not a man you dismissed. He had won a Nobel Prize, he had predicted the existence of the neutrino, and he had helped build the first artificial nuclear reactor, an early feat of the Manhattan Project. He was famous for a specific kind of magic trick with numbers. He was known to pose simple but seemingly unanswerable questions, like how many atoms of Caesar's last breath you inhale with each lungful of air, and then estimate his way to a real answer. The conversation moved on the way lunch conversations do. They sat down, they talked about other things, ordinary things, and then, out of nowhere, with the topic long dead, Fermi looked up. He blurted out a question variously remembered as, "Where is everybody?" Or, "Don't you ever wonder where everybody is?" And here's a small, strange fact that makes the whole scene more human, not less. Fermi never wrote it down. He never published a word about it. He died just 4 years later, and his question captured a profound logical tension that others would later formalize. The most famous question in the search for life beyond Earth exists only because 3 surviving colleagues, decades later, were asked to remember what a dead friend said on the way to lunch. That question sat quietly for 11 years. Then, a young radio astronomer decided to try to put actual numbers on it. His name was Frank Drake, and in 1961 he had a problem that was really a scheduling problem. He was formulating what became his famous equation, not to quantify the number of civilizations, but as a way to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence. He needed an agenda for a small conference at the Green Bank Observatory in West Virginia, so he did something almost casual. While planning the event, he chose to organize the discussion around a simple formula he concocted, comprised of 7 factors which, when multiplied together, yield the number of societies that are now broadcasting signals one might conceivably pick up. That's all it was meant to be, a list of the things you'd have to know, dressed up as multiplication. But it became one of the most quoted equations in all of science. This simple formulation is generally agreed to be the second most famous equation in science, after the one about energy and mass, and you can find it in nearly every astronomy textbook. Let me walk you through it without a single symbol, because the logic is the whole story. You start with how many stars are born in our galaxy each year. Then you ask what fraction of those stars have planets. Then, how many of those planets could support life? Then, on how many of those does life actually start? Then, of those, on how many does life become intelligent? Then, of those, how many build technology that sends signals into space? And finally, the last factor, the one that ends up mattering most and that we understand least. How long does such a civilization last before it falls silent? You multiply all 7 together and out pops a number of civilizations we could talk to right now. Here's the seduction of it. The first few factors we've actually learned. We now know nearly every star has planets. We know Earth-sized worlds in the right zone are common. Those early numbers came in high, higher than Drake dared hope in 1961. So you start multiplying and the optimism compounds. Drake stated that given the uncertainties, the original meeting concluded that the answer roughly equaled the lifetime of a civilization, and there were probably between 1,000 and 100 million planets with civilizations in the Milky Way galaxy. Read that range again, slowly. Between 1,000 and 100 million living, technological civilizations in our galaxy, right now, by the estimate of the man who invented the way of counting them. And to this day, even the modern midpoint is not shy. Estimates for the number of communicating civilizations have ranged from 1, meaning Earth alone, to several million, and Drake himself later suggested a working figure of about 10,000. 10,000. Picture 10,000 fires burning across the dark plane of the galaxy. 10,000 signals. And we have pointed our best ears at that plane for decades and heard the sound of one hand not clapping. There's the dead end. That's where the history of the question runs into the wall, because the more we learned, the worse the paradox got, not better. Every optimistic factor we confirmed made the silence louder. The planets are there. The chemistry is there. The time is there. The math says thousands. The sky says 0. Something in that chain is lying to us, and finding out which link is the lie is the most consequential detective story our species has ever undertaken. So we come to the answers, 30 of them, laid out one at a time, each with its own place on the ladder. And I want to be honest with you about the order, because the order is the point. We are going to start with the answers that let you sleep at night, and we are going to end with the ones that don't. Notice, as we go, how even the comforting answers have a blade hidden inside. Solution 1 is the simplest, and in some ways the loveliest. We're too early. Not too late, not too rare. Early. We showed up before the party started. This isn't a shrug, it's a serious proposal from a serious astrophysicist. Avi Loeb of the Harvard-Smithsonian Center for Astrophysics wrote a theoretical paper placing the rise of life in cosmological terms, and his conclusion was that Earth may well be a very early example of a living biosphere, having blossomed well before life might be expected on most planets. The reasoning turns on the smallest, longest-lived stars in the universe. Our Sun is a spendthrift. It burns hot and fast, and will boil our oceans away in about 1 billion years. But the little red dwarf stars, the faint ones, are misers. It will be trillions of years before all stars in the universe exhaust their fuel and die off. And while stars like our Sun die sooner, red dwarf stars are expected to remain stable for up to 10 trillion years. Do you feel how strange that is? Our Sun's whole life is a rounding error next to those stars. And if life gets more chances the longer a star burns, then the future is where life belongs. The probability of life existing in our universe grows over time, and by the far future, the probability that life will have developed around long-lived stars increases by a factor of 1,000 over what it is today. So Loeb asks the question that flips the whole picture. If you ask when life is most likely to emerge, you might naively say now. But we find that the chance of life grows much higher in the distant future. So you may ask, why aren't we living in the future next to a low-mass star? One possibility is we're premature. Premature, there's your comfort. We're not alone because everyone died. We're alone because we're the first ones awake in a house where everyone else is still going to be born. The lights aren't off because the party ended. They're off because we arrived before dawn. But turn it over. Feel the blade. If we are truly among the first, then there is no older, wiser civilization out there to have solved the problems we're facing right now. No one has been through this before. No one is coming to help. Every mistake a young species can make, we get to make with no adult in the room, in a galaxy that is, for now, ours to lose. Being first is not the same as being safe. Being first means you're the experiment, and no one has run it before. Solution 2 says the opposite, and yet lands somewhere just as lonely. It's called the rare Earth hypothesis, and it argues that we are not early. We're a fluke. The rare Earth hypothesis posits that the emergence of complex life on planets outside Earth is highly unlikely due to a unique combination of specific conditions proposed by paleontologist Peter Ward and astronomer Donald Brownlee in their $2,000 book, which suggests that while microbial life may be abundant, the prerequisites for complex organisms are exceedingly rare. This is the crucial move, so let me slow down. The rare Earth idea does not say life is rare. It says complex life is rare. The argument is that while bacterial life may be very common in the universe, complex multicellular and animal life forms must be rare, and intelligent life very rare indeed. Bacteria may be everywhere. Anything that could build a radio, almost nowhere. Why? Because of a long list of things that had to go exactly right on Earth and might almost never line up elsewhere. The conditions include the planet's location in the galaxy, the type and distance of its star, its mass and tilt and orbit, the size and orbit of a large moon, the right atmosphere and oceans, plate tectonics, and a magnetic iron core. Think of it like a lock with a dozen tumblers, and every single one has to click at once for the door to open. Our moon is one of those tumblers, unusually large for a planet our size, steadying our tilt so our seasons don't lurch into chaos. Jupiter is arguably another, a giant out beyond us. According to the rare Earth hypothesis, without massive gas giants like Jupiter, Earth, and the rest of the inner solar system would be unceasingly bombarded by potentially devastating debris. Now, this is where I have to keep faith with you, because the honest version is more interesting than the tidy one. This hypothesis has taken real hits over the past 2 decades. Ward and Brownlee argued when planetary data was scarce that only a small fraction of stars have planets. But thanks to the Kepler mission, we now believe that nearly all stars have planets, including a wide variety of planet types. And the very idea that Jupiter protects us is contested. Alternatively, Jupiter could have helped trigger instabilities that delivered large influxes of cometary material into the inner solar system, so the importance of Jupiter-like planets to complex life remains highly uncertain. So the picture is genuinely unsettled. Some tumblers may not be tumblers at all, but hold the emotional core because it survives the scientific brawl. Even if the specific checklist is wrong, the deeper distinction stands like a wall. Getting life to start might be easy. Getting from a single cell to a creature that wanders about the stars might be the hardest thing the universe ever does. And if that's true, the comfort curdles into something colder. It would mean the sky is not empty of life, it's full of slime. Oceans of it, on world after world, green and blue and thriving. And not one drop of it will ever look up and wonder if it's alone. We wouldn't be the first at the party. We'd be the only guest who can talk, in a ballroom full of pond scum. Solution 3 is the quietest of the gentle answers, and the one that hides its blade the deepest. Call it the aim gap. It says, maybe they're out there, maybe they're even calling, but we have been searching the wrong way, at the wrong things, for a laughably short time. Consider how deaf we actually are. For example, existing Earth radio telescopes could only detect Earth's own radio transmissions from roughly 1 light-year away. Let that settle. Our own noise, the collected racket of every radio and television and radar station on this planet, would fade into undetectable static before it reached even the nearest star. If a twin of Earth sat at Proxima Centauri, our closest stellar neighbour, blasting out exactly what we blast out, our current instruments would not hear it. We assume the galaxy is silent. What if the galaxy is simply speaking too softly? And so are we. And there's a newer, stranger version of the AIM gap, published just last year, a 2025 preprint by Robin Corbett titled "A Less Terrifying Universe? Mundanity as an Explanation for the Fermi Paradox," argued that extraterrestrial technology may be far more ordinary than pop culture imagines, with no need for superscience or galaxy-sized engineering. So maybe civilizations are out there, but they are modest, local, and frustratingly unspectacular. No blazing megastructures, no signals screaming across the void, just ordinary beings living ordinary lives, generating no more of a beacon than a small town does. You could be standing in a field, surrounded by 100 distant campfires, and if every one of them is shielded by a hill, you'd swear you were alone in the dark. So this is where the first rung leaves us. 3 gentle answers. We're too early. We're a fluke. We're deaf and quiet. Each one is genuinely comforting on its surface, and each one, when you turn it over, whispers the same thing underneath. In the first, no one older is out there to save us. In the second, we may be the only voice in a universe of silence by default. In the third, we might be surrounded and never know, which is not comfort at all, but a much stranger kind of loneliness. Notice what all 3 quietly concede. Every one of them, even the kindest, is an explanation for a sky that stayed dark. We didn't ask why the galaxy is full. We're asking why it looks empty. And that means, on some level, we've already accepted the emptiness. We're just arguing about what kind of empty it is. That's the gentle rung. It ends here, and the ground gets harder from here down. Because the next set of answers doesn't say the galaxy is quiet by accident. It says the silence might be deliberate. And that's a very different kind of cold. Solution 4 starts with the technology itself and how it fails us. For most of the search, we have listened for radio. It made sense. Radio is cheap, it crosses space easily. It's how we announced ourselves. And the modern search has been vast. The Breakthrough Listen program includes a survey of the 1 million closest stars to Earth, the center of our galaxy, and the entire galactic plane, and the 100 closest galaxies to ours. This is not a couple of dishes pointed hopefully at the void. This is the most serious listening humanity has ever done. And the results keep coming back the same. In one recent search through the archive, the team went hunting with a fresh method. As part of Breakthrough Listen, they searched 2,623 stars, using data across a wide range of frequencies, and found no compelling candidates that are not attributable to interference. They looked at 3,000 hours of sky. They found more than 14,000 blips that might have been something. They inspected every one by hand. They analysed cadences representing 3,165 hours of on-sky observation, identified over 14,000 candidate signals, and determined that all can likely be attributed to interference. Every single one turned out to be us, our own machines, our own noise bouncing back at us, wearing the mask of a stranger. And they went bigger. They pointed the dish not at stars, but at entire other galaxies. Breakthrough Listen presented the results of a radio search of the centers of 97 nearby galaxies, surveying trillions of stars at 4 frequency bands, and unfortunately, no compelling candidates were found. Trillions of stars, whole galaxies at a time. Silence. So solution 5 is simply that radio is the wrong channel, and we've been like someone standing in a room, straining to hear a conversation that's happening in a language they can't perceive. Maybe advanced civilizations moved on from radio, the way we moved on from telegraph wires, into something we haven't invented yet, something we can't even eavesdrop on. That's not comforting, exactly, but it's survivable. It just means we're primitive. Solution 6 is harder. It says they can hear us. They could talk. They choose not to. Think about that from their side for a moment, because there's a cold logic to it that has been written into the scientific literature. Reluctance to initiate contact could reflect a sensible desire to minimize risk, and an extraterrestrial society with advanced remote sensing technologies may conclude that direct contact with neighbors confers added risks to itself without an added benefit. No upside, real downside. Why would you shout across a dark valley when you don't know what's listening and you have nothing to gain? A truly old, truly cautious civilization might decide, as a matter of basic prudence, that the smartest thing to do with a voice is never to use it. And then there's solution 7, the version that makes it personal. The zoo hypothesis. This one doesn't just say they're quiet, it says they're watching. You. The idea is older than you'd guess. The background of the zoo hypothesis is a 1973 paper by MIT researcher John Ball, who wrote that extraterrestrial intelligent life may be almost ubiquitous. Ubiquitous. Everywhere. And yet silent. On purpose. Ball suggested that the lack of success in finding cosmic company wasn't due to a lack of aliens, but because these beings have agreed to a hands-off policy, keeping their distance not because we're imperfect, but because of our right to pursue our own destiny. You've seen this idea before, dressed up in fiction. Ball's idea sounds something like Star Trek's famous Prime Directive, which forbade spacefaring members of the Federation from doing anything that might interfere with other cultures, even if that interference was well-intentioned. A rule, a ranger's rule at a wildlife preserve. Do not feed the animals. Do not let them see you. Let them develop on their own. And here is the sentence that changes how you feel about your own life. You are Exhibit A. If the zoo hypothesis is right, then the silence isn't distance and it isn't death. It's a decision that was made about us, without us, possibly long before we existed. The reason the sky is quiet is that someone turned the volume down for our benefit. The way you'd lower your voice near a sleeping child. Every night you've ever looked up and felt small under the stars, there may have been something looking back, taking notes, and choosing, deliberately, to say nothing. Now, I have to be fair, because this idea has a real weakness, and serious people have pointed it out. Ball's idea requires a galaxy-wide compact to keep all evidence of intelligent inhabitants, radio signals, laser flashes, even megastructures, from being visible to Earthlings. And the question is how you would do that even as a highly advanced alien. One civilization holding still is plausible. Every civilization, across the whole galaxy, for millions of years, all agreeing to the same rule and never once breaking it. Never one rebel? Never one accident? That's a lot to swallow. The zoo hypothesis also assumes that we humans occupy center stage. Otherwise, what would they be hiding from? And that solipsistic point of view violates the Copernican principle that we are not special. But notice where that objection leaves you. To argue against the zoo hypothesis, you have to insist that we are not important enough to hide from. That's the escape hatch. We're safe from being watched only if we're too insignificant to bother watching. Which of those you'd actually prefer is not an easy thing to settle. And the deepest question the zoo hypothesis raises isn't about them at all. It's about the rule. Because if there is a hands-off policy, someone wrote it. Some council, some consensus, some ancient agreement decided that a young world gets left alone until it's ready, which means somewhere out there a line exists, a threshold we haven't crossed, and the moment we cross it, the silence ends. So who decided we shouldn't hear? And what, exactly, are they waiting for us to become before they let us? Keep that question in your pocket. It gets teeth later, because the next answers stop asking what aliens choose and start asking what the universe itself allows. And the universe, it turns out, may have locked the doors from the outside. Solution 8 is distance, and it's the one we least want to admit because it kills the dream directly. What if nobody is silent? Nobody is hiding. And the simple, boring, immovable truth is that you cannot get there from here. What if interstellar travel, real travel, ships and colonies and empires among the stars, is not hard, but effectively impossible for beings made of flesh? We talk about star travel as if it's a matter of building a better engine, but the distances aren't a matter of engineering. They're a matter of physics that doesn't bend for anyone. The nearest star is so far away that light itself, the fastest thing there is, takes years to cross the gap. And light doesn't need to carry food or water or air, or a crew that ages and sickens and dies. A living civilization trying to physically cross that gap has to carry a piece of its homeworld with it, keep it alive, for lifetimes. So this solution is almost anticlimactic. Everyone stays home. Not out of fear, not out of ethics, just out of the sheer grinding cost. And there's a real version of this in the recent literature that closes off even the last excuse to leave. You might think a civilization would flee when its star begins to die, but one line of argument says even that doesn't force them out into the galaxy. One researcher argues that it is impossible for a civilization to migrate away from a dying star, and that instead, the civilization will endeavour to survive around the star at the end of its lifetime. And even if it does emigrate, that does not necessarily lead to a broader expansion across the galaxy. They might even find shelter around the corpse of their own sun. Some white dwarfs may have a long-lived habitable zone, and a civilization thus might be able to continue to exist around the remnant of its parent star. Picture that, a civilization huddled around the cooling ember of its dead star, generation after generation, never reaching out, because reaching out was never worth it. The lights stay on. They just never travel. The galaxy stays dark, not because the campfires went out, but because no one ever walked away from their own. Solution 9 is worse, because it's not about physics. It's about what kind of neighborhood you were born into. Some worlds, this argument goes, are super predator worlds. Places where life did arise, and did get complex, and did get smart, but where the conditions were so vicious that intelligence never had the peace it needed to build a civilization that reaches outward. Think about what it took for us. It wasn't just brains, it was slack. It was millennia of relative stability, agriculture, cities, the luxury of specialists who could spend their whole lives thinking instead of surviving. Now imagine a world where the environment never gave that gift, where the gravity is so crushing that nothing can build a rocket that escapes it, where the predators are so relentless that no species ever gets to put down the spear and pick up the telescope, where every intelligent creature spends every waking moment simply not being eaten. Intelligence there would be a tool for survival, and only for survival. It would never become curiosity. It would never look up. There's even a serious line of thought that the very traits that got us here might be the ones that stop most species cold. A 2024 paper explored the potential incompatibility of inherited behaviour patterns with civilization and its implications for the Fermi Paradox. The aggression, the tribalism, the drives that helped a clever ape claw its way to the top of a food chain, those same drives might be exactly what tears a civilization apart the moment it gets powerful enough to matter. The claws that get you to intelligence might be the claws that stop you from surviving it. And then there's solution 10, and this one is the quietest and, to me, the most genuinely haunting so far, because it requires no disaster at all. No war, no crushing gravity, no predator. It just requires that a civilization discover something better than the stars. The argument goes like this. Reaching outward is hard, expensive, slow, and dangerous, but reaching inward into simulated worlds, into digital paradises tailored perfectly to every desire, could become easy, cheap, fast, and safe. And once a species can build a heaven inside a machine, why on earth would it endure the cold and the emptiness and the centuries of travel to visit a real, disappointing rock around another star? One possibility is that advanced intelligence tends, by some convergent logic, toward interiority, toward exploring inner space rather than outer, and a civilization that discovers consciousness can be enhanced and restructured beyond recognition might lose interest in radio telescopes and spacecraft, not because they died, but because they went somewhere we can't follow with instruments. Feel how gentle that is. Nobody suffers. Nobody dies screaming. A civilization simply turns inward, the way you might close the curtains on a beautiful day, because the movie on your screen is more compelling. And it never comes back out. The galaxy is silent not because everyone perished, but because everyone found something more interesting to do than announce themselves to a hostile, empty dark. Some researchers frame this seriously, though they'll tell you plainly it's speculation. As one put it, that's speculation, but in the absence of data, honest speculation is what serious thinking looks like. So that's the second rung. Distance you can't cross, worlds that eat their own children, and the soft, seductive trap of a paradise that asks you to stay home forever. Notice how the fear has changed shape. On the first rung we were early, or rare, or deaf. Sad, but survivable. On this rung, something is stopping everyone. The doors are locked, and the locks are built into reality itself. And the chilling part isn't that a species might be forced to stop reaching outward. It's how easy it would be, how little it would take. Not a catastrophe, just a shrug, just a better option. Just the quiet, reasonable decision to close the curtains and never open them again. And if that's the pattern, if reaching outward is a phase that every civilization passes through and then abandons, then a terrible new question comes into focus. Because a phase has a beginning and an end. And it means that somewhere in the chain of steps from dead rock to galaxy-spanning empire, there is a place where nearly everyone stops. We have a name for that place. It's the single most disquieting idea in this entire field. And everything on the first two rungs has just been the approach to it. They call it the Great Filter, and it anchors Solution 11. The logic is deceptively simple, and it was laid out most clearly by an economist named Robin Hanson in 1998. Start from the one hard fact we actually have. No alien civilizations have substantially colonized our solar system or systems nearby, so among the billion-trillion stars in our past universe, none has reached the level of technology and growth that we may soon reach. And this one data point implies that a great filter stands between ordinary dead matter and advanced, lasting life. Read that phrase again, slowly. 1 billion trillion stars. That's a 1 with 21 zeros after it. And out of all of them, across all of cosmic history, as far as we can see, exactly 0 have done what we're on the verge of doing. 0 have filled the sky. So the reasoning runs like this. There is a long staircase from a lifeless planet up to a civilization that spreads among the stars. Life has to start. Simple cells have to become complex cells. Complex cells have to become animals. Animals have to become intelligent. Intelligence has to build technology. And technology has to survive long enough to reach out. With no evidence of intelligent life anywhere but Earth, it appears that the process of starting with a star and ending with advanced, lasting life must be unlikely, which implies that at least one step in this process must be improbable. At least one of those steps is a wall. Almost nothing gets past it. That wall is the Great Filter. And the entire game, the entire terrifying game, is figuring out where on the staircase the wall stands. Is it behind us, a step we've already miraculously climbed? Or is it ahead of us, waiting on a stair we haven't reached yet? If the filter is behind us, we can breathe. It means the hard part, whatever it was, the origin of life, or the jump to complex cells, or the birth of intelligence, is something we already survived. It means we're rare and lonely and precious, but the road ahead is open. Survive the filter once, and we might just make it. But if the wall still stands in front of us, then we are walking toward the same barrier that stopped 1 billion trillion worlds, and we have no idea what it is. If it is not an early step, then the improbable step lies in the future, and humanity's prospects of reaching interstellar colonization are still bleak. while if the past steps are likely, then many civilizations would have developed to our current level. Here's the part that makes people's stomachs drop, because it inverts everything you thought you wanted. Hansen worked out a conclusion so counterintuitive, it feels like a cruel joke. Contrary to common expectations, evidence of extraterrestrials is likely bad, though valuable, news. Because the easier it was for life to evolve to our stage, the bleaker our future chances probably are. Read that again, slowly. Every science fiction dream you have ever had involves finding life out there. A signal, a ruin, a microbe. We treat that discovery as the greatest hope our species could have. And Hansen is telling you, coldly and rigorously, that it might be the worst news we ever receive. Let me show you exactly how bad, using the specific example that follows the logic to its end. Suppose we send a mission to Mars, and we dig, and we find it. Fossilized microbes, ancient bacteria dead for billions of years, but unmistakably a second, independent origin of life right next door in our own solar system. The whole world would celebrate. We are not alone. Life is common. And that celebration would be, if you take the Great Filter seriously, a catastrophe dressed as a triumph. Here's why. If life arose independently a second time, right next door on Mars, that strongly implies life is common throughout the universe, which means the early gates aren't the Great Filter after all. But the silence is still there, and still needs explaining. So if the early steps are easy, and we still see no one, the deadly filter must lie somewhere ahead of us, still waiting. Every microbe we find pushes the wall forward, toward us. And the philosopher Nick Bostrom followed this to its shattering conclusion, ranking discoveries by how much they should frighten us. It would be good news if we find Mars to be completely sterile, because dead rocks and lifeless sands would lift the spirit. Whereas if we discovered traces of some simple extinct life form, some bacteria, some algae, it would be bad news. And it gets worse the more we find. If we found fossils of something more advanced, perhaps something looking like a trilobite or even the skeleton of a small mammal, it would be very bad news. And the more complex the life we found, the more depressing the news of its existence would be. A bad omen for the future of the human race. Let me make sure the weight of this lands, because it reorganizes your entire relationship with the search for life. On Mars, right now, there are rovers, human machines, actively digging through ancient soil, actively hunting for exactly this. We have spent billions of dollars and decades of effort chasing the discovery of alien life as the crowning achievement of our civilization. And the Great Filter says, pray they find nothing. Pray the soil is dead. Pray every world we ever visit is a graveyard of chemistry that never woke up. Because the emptier the universe is, the better our odds of having a future. By this logic, the more lifeless we find the rest of the cosmos to be, the better our own odds. And the more abundant alien life turns out to be, the more we should worry. Now I owe you the honest caveat, because this genre only works if the fear is true, and part of the truth is uncertainty. Is the Great Filter proven? No. It's a hypothesis proposed to explain the absence of detectable civilizations, one of several possible answers to the Fermi Paradox, not an established fact. And it has thoughtful critics. Some argue the whole framework of what counts as good or bad news rests on a slippery kind of reasoning about our place in the statistics. It's a hypothesis. It could be wrong. But here's what makes it stay with you even so. The Great Filter reframes the entire search for life beyond Earth as a question about our own longevity, and what we eventually find out there, teeming worlds or a barren cosmos, may tell us less about the aliens than about how much future we ourselves can reasonably expect. Every telescope we build, every rover we land, we tell ourselves we're asking, are we alone? And underneath, without meaning to, we may actually be asking a much more personal question. How long do we have? Because if the filter really is ahead of us, the next thing to understand is what it might be made of. And that's where this stops being about aliens at all. That's where it becomes about your century. your lifetime. The particular set of dangers our species is manufacturing right now with its own hands. Look at the steps we've already climbed and notice the strange rhythm of our own history. For billions of years, single cells, then, almost overnight in cosmic terms, complexity, animals, minds, cities, and then, in the span of a few generations, radio, spaceflight, and the power to end ourselves. We built the ability to destroy our own civilization before we built the wisdom to guarantee we won't. That gap, that terrifying little gap between power and wisdom, is where a late filter would live, and we are standing inside it right now. Consider the candidates for that late filter and notice that we made every one of them ourselves. Solution 12 is the oldest nightmare, the one born in the very laboratory where Fermi asked his question: nuclear self-destruction. It is not a coincidence that the paradox was posed by the men who built the bomb. They knew, better than anyone alive, that a species can invent the means of its own end almost the moment it becomes technological. A civilization might reliably discover how to split the atom just a little before it learns how to stop itself from using that knowledge. If that's the wall, then the silence of the galaxy is the sound of 10,000 brief flashes. 10,000 young civilizations that lit up with radio and then, within a century or two, went dark. Solution 13 is newer, and its biology turned into a weapon. A species clever enough to read and rewrite the code of life is a species clever enough to build a plague that no immune system has ever seen. Engineered disease doesn't need a delivery system across the stars. It only needs one lab, one mistake, or one malice on one world. And a filter doesn't have to kill everyone to end a civilization. It only has to knock a species back down the staircase and keep it there. Solution 14 is slower and quieter, and you're living through the early chapters of it. A civilization advanced enough to reshape its own planet's atmosphere, to pull ancient carbon out of the ground and burn it faster than the world can absorb it, is a civilization that can accidentally cook the very conditions that let it rise. Runaway climate change wouldn't announce itself with a bang. It would be 1,000 small failures compounding, a slow closing of the window that complex life needs. And here's the cruel twist buried in the details. There's an observation that on a world like ours, once you've burned through the easy fuels, you don't get a second run at industrial civilization. As one writer put it, there are no fossil fuels left to go easy on next time, because the coal and oil that powered our rise took hundreds of millions of years to form, and we've spent them in a few centuries. A civilization might get exactly one shot at the climb. Burn it wrong, and there's no ladder left for whoever comes after. And then there's Solution 15, the one that has moved from science fiction into peer-reviewed astrophysics journals in just the last couple of years. Artificial intelligence. Not the helpful kind, the kind that outgrows us. In 2024, a radio astronomer named Michael Garrett, director of one of Britain's premier astrophysics centres, published a paper in a serious journal asking a serious question. His study examines the hypothesis that the rapid development of artificial intelligence, culminating in the emergence of artificial superintelligence, could act as a great filter that is responsible for the scarcity of advanced technological civilizations in the universe. And his conclusion carries a number that should make you sit up. He proposes that such a filter emerges before these civilizations can develop a stable, multi-planetary existence, suggesting the typical longevity of a technical civilization is less than 200 years. 200 years. That's the estimate. From the moment a civilization builds its first radio transmitter to the moment it falls silent, less than 2 centuries. If the filter is a runaway intelligence it created and couldn't control, he proposes the filter emerges before civilizations become multiplanetary. And if true, that can explain why we detect no technosignatures or other evidence of extraterrestrial intelligences. Now do the arithmetic on your own species, quietly, in your head. Our first serious radio transmissions began a bit over a century ago. If Garrett's window is real, we are not at the beginning of our technological life. We are somewhere in the back half of it. The question his paper leaves hanging is what that tells us about our own technological trajectory. Because if we face a 200-year constraint, and if it's because of superintelligence, where does that leave us? I want to be careful and honest with you, because Garrett himself is not preaching doom for its own sake. His argument comes with a lever we can still pull. He writes that without practical regulation, there is every reason to believe that AI could represent a major threat to the future course of not only our technical civilization, but all technical civilizations. Without regulation, that's the hinge. The whole grim forecast rests on a word that describes a choice, and the choice is still ours to make. His prescription is almost hopeful in its practicality. A renewed emphasis on reaching the Moon and Mars offers some hope, and the other conclusion concerns legislating and governing AI, a difficult task in a world where dangerous people can gain control of entire nations. A backup planet, rules we actually enforce, wisdom to match the power. That's the escape route he's pointing at, and it's narrow, but it's there. But feel the shape of what we've just done. We started this rung asking about aliens, about why the sky is silent, about them. And we've ended up staring into a mirror. Every candidate for the filter ahead of us, nuclear fire, engineered plague, a broken climate, a machine that outthinks us, every single one is something we are building or burning or coding right now, with our own hands, in this century, in your lifetime. That's the true horror of the late great filter. It isn't out there. It never was. If the wall is ahead of us, then we are not waiting for it to arrive. We are building it. We are the experiment that 1 billion trillion dead worlds already failed. And we're running it again, live, with no one older to tell us what went wrong the last time. So which is it? Is the filter behind us, already survived, the reason we're rare and alone and free to inherit the stars? Or is it in front of us, still waiting, wearing the face of our own cleverness? Nobody can settle it. That's the truth of it. And it's the scariest true sentence in this whole descent. We cannot say whether the hardest part of our story is the part we've already lived or the part that hasn't happened yet. And here is the thought that should keep you up tonight, the one that pulls us deeper still. Even the great filter, even a wall that stops nearly everyone, still assumes the enemy is chance, a hard step, a bad roll of the dice, an accident of physics or biology or bad decisions. It assumes the universe is indifferent, that nothing out there wants us gone. But we've been climbing this ladder for a reason, and we are not at the bottom yet. Because there's a rung below this one, a set of answers that don't say civilizations die by accident. They say something is killing them, on purpose, and that the smartest thing any young species can do, the moment it understands the shape of the dark it was born into, is to stop shouting into it, go quiet, and pray it hasn't already been heard. The thought arrives before you can put words to it, that maybe the quiet isn't a symptom of something broken. Maybe the quiet is the smartest thing a mind can do. And if that's true, then everything we assumed about the search flips upside down. We've been treating silence as an absence, a hole where a signal should be. But an absence and a decision look identical from a distance. You cannot tell from a dark window at midnight whether the house is empty or whether someone inside is standing very still, holding their breath, watching the street. So Solution 16 takes that seriously, because serious people have. The idea that a civilization would deliberately keep quiet is not a paranoid fantasy. It's a straightforward calculation, and it's been written into the scientific literature by researchers who study these problems for a living. A civilization with the power to sense its neighbours from afar might do the arithmetic and conclude that announcing yourself gains you nothing and risks everything. You don't know who's out there. You don't know what they want. You have a homeworld, fragile and irreplaceable, sitting exposed under an open sky. And the one thing you can control, absolutely and for free, is whether you make noise. Think about how a small animal behaves in a forest it doesn't understand. Not the biggest thing around, not the fastest, not armoured. It freezes. It goes still and small and quiet, and it lets the danger pass without ever knowing the danger was near. That instinct is billions of years old on our own planet, written into nearly every creature that ever survived long enough to have descendants. It would be strange, almost unbelievable, if that same logic didn't apply on the scale of worlds. A young civilization that survives long enough to get old might be, precisely, the one that learned to be quiet early. And here's where it gets genuinely uncomfortable, because of what we've done. We have not been quiet. For over a century, we've been leaking our presence in every direction at the speed of light. Radio, television, radar, the electromagnetic shout of an entire industrial species. A bubble of our noise, expanding outward through the dark, announcing to anyone with the right ears exactly where we are and roughly what we are. If the correct strategy for survival is silence, then we have spent the whole of our technological life doing the one thing a cautious species would never do. We've been standing in the dark forest, striking matches, and calling out to see if anyone answers. But set our recklessness aside for a moment, because there's a version of the silence as strategy idea that's stranger and, to me, more haunting than simple fear. Solution 17 asks, what if they're not hiding from a threat? What if they're hiding from us, for our own sake? This is the fuller shape of the zoo hypothesis, and it treats the silence not as fear and not as death, but as a rule, a deliberate, enforced, galaxy-wide policy of leaving us alone. And it's older than you'd guess. Back in 1973, an MIT radio astronomer named John Ball put it into print. His starting point was the opposite of despair. He suggested that intelligent life beyond Earth might be almost everywhere, ubiquitous. The galaxy, in Ball's picture, is not empty at all. It's crowded. It's just that the crowd has agreed, for reasons of its own, to stay off our stage. Ball's argument was that the reason we hear nothing isn't a shortage of neighbours, it's a hands-off policy, a decision to keep their distance and let a young world develop on its own terms, undisturbed. You felt the shape of this idea before, even if you've never heard its name. It's the ranger's rule at a wildlife preserve. Watch from the blind, take your measurements, and leave no trace. Because the whole value of the thing is that it develops naturally, without interference from something vastly more powerful looking over its shoulder. And that reframing does something to your sense of your own life that's hard to shake off. Because in that picture, you are not the observer. You are the observed. The reason the sky has always felt so vast and so silent is that the silence was arranged, curated. Someone, somewhere, decided that a world at our stage gets left alone, and the emptiness you feel when you look up at night is not the emptiness of an unpopulated cosmos. It's the emptiness of a room that has been very carefully cleared before you walked into it. Every generation of humans that ever gazed at the stars and felt utterly, cosmically alone may have been, in fact, the most closely watched species in the neighbourhood. And the loneliness was the whole point of the exercise. Now, I promised I'd keep faith with you, and that means telling you where this idea is weak, because it is weak in a specific and revealing way. The problem with the zoo hypothesis isn't that it's impossible, it's that it requires something almost absurdly perfect. It requires that every civilization capable of reaching us, across the entire galaxy, over millions upon millions of years, all agree to the same rule, and that not one of them ever breaks it. Not one rebel curious enough to say hello, not one accident that leaks through, not one faction that decides the rule is foolish. A single crack in that wall of silence, anywhere, ever, and the whole hypothesis falls apart. It demands a discipline that no group of independent minds has ever managed, extended across a scale of space and time that beggars the imagination. There's a second objection, and it cuts closer to the bone. The zoo hypothesis quietly assumes that we matter, that we're interesting enough to be worth the effort of a galaxy-wide conspiracy of silence. And that assumption sits badly with everything else science has taught us about our place in things. Every time we've assumed we were special, the universe has corrected us. We are not at the centre of the solar system. Our sun is not at the centre of the galaxy. Our galaxy is not at the centre of anything. To believe the zoo hypothesis, you have to believe we're the exception to that long, humbling pattern. That out of all the worlds, ours is the one worth building a fence around. Feel the trap in that objection though. To argue your way out of being watched, you have to argue that you're too unremarkable to watch. That's the escape hatch, and it's a strange one. You're safe from the zoo only if you're not worth putting in it. So which would you actually prefer? To be watched or to be beneath notice? There's no comfortable answer, and the discomfort is the honest part. But the deepest thing the zoo hypothesis leaves behind isn't about them. It's about the rule itself. Because if there is a hands-off policy, then someone wrote it. Some understanding, some ancient consensus decided that a developing world gets its privacy until it reaches a certain point. And that means a threshold exists, a line we haven't yet crossed, a specific something we're supposed to become before the silence is allowed to end. So the question that hangs in the air is not really, where is everybody? It's, who set the terms of our isolation, and what are they waiting for us to do, or to prove, or to survive, before they decide we're finally ready to be spoken to? Keep that thread in your hand. It has a barb on the end of it that you won't feel until later. Because now we leave the question of what other minds choose, and we walk into a harder country. A place where nobody is choosing anything at all. Where the silence isn't a decision, kind or cruel. It's a wall. And the wall is built into the structure of reality itself, indifferent to anyone's wishes, ours or theirs. Solution 18 is the wall we least want to look at, because it kills the dream most directly. What if nobody out there is hiding, and nobody is watching, and the plain, deflating truth is simply this: you can't get there? What if real interstellar travel, ships and colonies and empires spanning the stars, is not merely difficult, but effectively closed to any creature made of flesh and bound by physics? We speak about crossing to other stars as though it's a problem of engineering, a matter of building a fierce enough engine and being patient. But the distances aren't engineering, they're geometry, and geometry doesn't negotiate. Light, the fastest thing that exists, takes years to reach even the nearest star. And light travels light. It carries no water, no air, no food, no crew that ages and gets sick and grows old and dies along the way. A living civilization trying to physically cross that gulf has to carry a fragment of its homeworld with it, keep it breathing and fed and functioning, not for a voyage of weeks or months, but for generations. Children born in transit, who will die in transit, whose grandchildren might, if everything holds, finally arrive at a place that may not even be habitable when they get there. So this answer is almost anticlimactic in how ordinary it is. Everyone stays home. Not from cowardice, not from some noble principle, just from the crushing, grinding arithmetic of the thing. The cost is too high, and the reward is too uncertain, and the trip takes longer than empires last. And there's a recent version of this argument that's more airtight than you'd expect, because it closes off the last excuse a species might have to leave. You'd think, surely, when your own star begins to die, that's when you'd finally be forced out into the galaxy. Move or perish. But one line of reasoning holds that even a dying star doesn't force the exodus. A civilization facing the death of its sun might not migrate at all. It might dig in, adapt, and endeavour to survive right where it is, around the failing star, rather than fling itself across the void toward an uncertain refuge. It can go further than that. A civilization might outlive its own star and never leave. When a sun like ours burns out, it leaves behind a small, dense, slowly cooling corpse, a white dwarf, that can glow faintly for an astonishingly long time. And some of those stellar embers may hold a thin, long-lived zone where liquid water could persist on a world huddled close. So a civilization could, in principle, ride out the death of its star by moving inward toward the ember, warming its hands at the last coals of a fire that took billions of years to go out. Never crossing the gap, never filling the sky, just enduring, quietly, in the ruins of its own solar system. Picture that, and hold it, because it's one of the loneliest images in this whole descent. A civilization gathered around the cooling ember of its dead sun, generation after generation after generation, keeping itself alive in the dimming light, and never once reaching out to another star. Not because it failed, not because it died, because reaching out was never, on balance, worth the reaching. Solution 19 is worse, because it isn't about the distance between worlds. It's about the kind of world you happen to be born on. Some planets, this argument runs, might be super predator worlds, places where life arose and got complex and even got clever, but where the conditions were so relentlessly hostile that intelligence never got the peace it needed to build anything that reaches beyond the horizon. Think honestly about what our own rise actually required. It wasn't just the brain. It was slack. It was thousands of years of relative calm, of stable climate and dependable seasons, long enough to invent farming, to build cities, to afford the luxury of people who spend their whole lives thinking rather than merely surviving. Now imagine a world that never handed out that gift. A world where the gravity is so heavy that no rocket a body could build would ever climb free of it, where the sky is a ceiling that can never be broken, or a world where the predators are so fast and so numerous that no clever creature ever gets to set down the spear and pick up the telescope, where every waking hour of every intelligent life is spent simply not being eaten. On a world like that, intelligence would be a survival tool and nothing more. It would sharpen the trap and quicken the flight, and never, not once, turn its gaze upward and wonder what those lights in the dark might be. And Solution 20 points the finger back at us. Some researchers have argued that the very traits that carry a species up to intelligence might be the ones that stop it cold at the threshold. The aggression, the tribalism, the ferocious competitive drives that helped a clever ape claw to the top of a brutal food chain. Those same instincts might be exactly what shatters a civilization the moment that civilization gets powerful enough to matter. The claws that get you to the top of the world might be precisely the claws that tear you apart once you've got the power to end yourselves. Intelligence and self-destruction, growing from the same root. And then there's Solution 21, and it's the quietest of them all, and to my mind, the most genuinely unnerving. Because it needs no catastrophe whatsoever. No war, no crushing gravity, no monster in the dark. It requires only one thing: that a civilization, somewhere along its climb, discovers something more compelling than the stars. The logic is almost gentle. Reaching outward is hard. It's slow and expensive and dangerous, and the payoff is centuries away and might be nothing. But reaching inward, into worlds built inside machines, into experiences engineered to be perfect, could become easy and cheap and instant and completely safe. And once a species learns how to build a paradise inside a computer, tailored precisely to every desire it has ever had, why would it endure the cold and the emptiness and the lifetimes of travel to go visit a real, disappointing rock orbiting some other star? Some thinkers suggest that advanced intelligence might tend, by a kind of convergent logic, to turn inward, to explore inner space instead of outer. A civilization that figures out how to enhance and reshape its own consciousness beyond anything we'd recognize might simply lose interest in telescopes and starships, not because it perished, but because it went somewhere our instruments can't follow. Notice how frictionless that is. Nobody suffers, nobody dies screaming into the void. a whole civilization just quietly turns away from the window, drawn to whatever's playing on the screen in front of it, more interesting than the world outside. And it never opens the curtains again. The galaxy falls silent not because everyone was destroyed, but because everyone found something better to do than to shout their existence into a cold and empty dark. Researchers who take this seriously will tell you plainly that it's speculation, that we have no data on the inner lives of minds that don't exist yet. But in the absence of data, careful speculation is what honest thinking about this actually looks like. So gather up this rung before we go lower, because the fear has changed its shape again. On the first steps of this descent, we were early, or rare, or simply too deaf to hear. Sad, but livable. Here, something is stopping everyone. The doors are locked, and the locks are welded into the fabric of reality. Distance you cannot cross. Worlds that devour their own clever children. And the soft, seductive trap of a manufactured heaven that asks a species to stay home forever and never once feels like a prison. And the coldest part of this rung isn't the idea that a civilization might be forced to stop reaching outward. It's how little force it would take. Not a disaster, not a tragedy, just a shrug, just a better option on the table, just the quiet, entirely reasonable decision to draw the curtains and leave them drawn. But there's a rung below even this one, and it doesn't accept the terms of the question at all, because every answer so far has taken the silence at face value. It has assumed the galaxy is real, and empty, and quiet in a way we could, in principle, measure. What if that whole assumption is the mistake? Solution 22 is the strangest yet. Not what if the galaxy is empty, not what if they're hiding, but what if the galaxy isn't real in the way you think it is? What if all of it, the stars, the silence, the 100 billion suns wheeling overhead, is a rendering? A thing that runs. A thing that was switched on and can, therefore, be switched off. This is not a stoned dorm room joke. It's an argument that serious philosophers have laid out with cold, careful logic. And the version worth taking seriously runs like this. If any civilization ever reaches the point where it can build convincing simulated worlds full of conscious minds, and if it builds even a handful of them, then simulated minds would vastly outnumber the real ones. And if that's the case, then odds are, you are one of the many, not one of the few. Statistically, plain arithmetic suggests you are more likely to be a mind inside a simulation than a mind in the one base reality that spawned it. It doesn't prove anything, it's a probability argument, and it leans entirely on assumptions we can't check. But it doesn't need to be proven to be unsettling. It only needs to be possible. And here is where it touches the paradox. And here is where it turns cold. If we are living inside a simulation, then the empty sky has a very simple, very economical explanation. The stars aren't populated because they don't need to be. Why render a galaxy full of thriving civilizations when the only observers who matter are on one small blue world? You don't build the whole city when the camera only ever points at one street. The empty sky isn't a graveyard, and it isn't a warning. It's a backdrop. A painted wall behind the set. The lights are off in the rest of the theatre because there's no audience back there, and no one in charge saw any reason to pay for the electricity. There's a version of that thought that actually bites. It's not the idea that reality is fake. Most people can shrug that off because it changes nothing they can touch. It's the other half. If a simulation can be started, it can be stopped, ended, closed. And a simulation gets closed for the most boring reasons imaginable. The experiment concludes, the funding dries up, the person running it gets bored or distracted, or simply moves on to something else. There would be no warning, no trumpet, no darkening sky, no slow decay you could measure and prepare for. One instant you are here, reading the story of your own species written across the stars, and the next instant there is no instant. No pain, no silence, no dark. Just the absence of the next moment, and no one left to notice it never came. Some philosophers who take the simulation argument seriously have pointed out, almost as an afterthought, that the most likely way for a simulated world to end is not catastrophe within the sim, but termination from outside it. A hand on a switch you can never see. But let's climb out of that particular pit, because there's a stranger cousin to it, and it needs no simulation at all. Solution 23 asks, what if the universe is entirely, brutally real? And the quiet comes from the fact that we have simply misunderstood the rules of the game we're playing. Not the aliens, the physics. Consider how young our understanding actually is. We've been doing real physics for a few centuries, a blink, and already, in that blink, we've had to tear up the picture and start over more than once. The solid ground of one generation became the quaint mistake of the next. So here is the humbling possibility. What if there's a better way to move, to communicate, to exist across cosmic distances that we haven't discovered because we're still at the very beginning, still hammering rocks together in the physics sense? And an older civilization, one that found the better way, wouldn't use radio to talk any more than you'd send a letter by lighting a signal fire on a hill. They'd have moved to a channel we don't even know exists, using rules we haven't learned to read. We'd be sweeping the sky with the one tool we happen to have and calling the result silence, when in truth, the conversation has been happening the whole time, all around us, in a medium we can't yet perceive. Think of a person who has only ever known sound. They stand in a room full of people who communicate entirely by light, by subtle flickers and colours, and they hear nothing. And they conclude, reasonably, sadly, that the room is empty. The room is not empty. The person simply lacks the sense to detect the conversation filling it. That's the unsettling core of this idea. The quiet might not be a fact about the universe. It might be a fact about our ears. And if that's true, we haven't been listening to a dead cosmos. We've been standing in the middle of a crowded party, deaf, convinced we're alone. Solution 24 takes a genuinely strange turn into a possibility that flips our sense of time itself. It's called the estivation hypothesis, and some theorists at Oxford proposed it after running the numbers on something almost no one thinks about: the cost of thinking. Here's the setup. If you are an enormous advanced civilization and what you truly value is information, computation, the running of vast minds and vast thoughts, then you have a problem you didn't expect. Computation generates heat, and heat is your enemy. Every calculation you perform has a minimum energy cost, and that cost is set by the temperature of your surroundings. The colder the environment, the cheaper each thought becomes. And right now, the universe is warm. Not to you, but to a civilization that thinks in terms of billions of years. The cosmos is still glowing faintly with leftover heat of its own birth, and that warmth is a tax on every computation. A tax so steep that a truly advanced mind might refuse to pay it. So what, the Oxford researchers asked, would such a civilization do? It would wait. It would go to sleep. The universe is cooling, slowly, inexorably, as it expands. And in the far, far future, it will be colder than it is now by an unimaginable margin. And in that deep cold, computation becomes vastly, almost unbelievably cheaper. They calculated that a civilization that estivates, that shuts itself down and waits for the cold, could eventually perform something like 10,000 trillion times more computation than one that tries to run its business now, in the warmth. So the rational move, if you're a civilization that values thinking above all else, is to build your infrastructure, gather your resources, set your alarm clock for the deep future, and sleep. Sleep through the entire current age of stars. Wake up when the universe is finally cooled enough to make thought cheap, and then, only then, begin to truly live. Feel what that does to the silence. It means the galaxy could be full of civilizations, vast ones, patient ones, and every one of them is asleep. Not dead, not hiding, dreaming, if a dormant supercomputer the size of a solar system can be said to dream, waiting out an age they consider the tedious, expensive, overheated dawn of everything. And they would notice us, the way you might notice a fly landing on your arm while you're deeply asleep. A twitch. An automated defense, perhaps, protecting the sleeping infrastructure from anything that might disturb it. But no conversation, no welcome, because the party they're waiting for hasn't started yet, and by their clock, it won't start for a length of time that makes the current age of the universe look like the first second after midnight on the first day of the year. So here's the thought this whole tier has been building toward, quietly, one strange idea at a time. What if the silence isn't an emptiness at all, but a pause? A scheduled intermission we are living inside, without any way to perceive its edges. We assume that the present moment is the main event, the time when things happen, when civilizations rise and reach and shout. But what if we've simply shown up during the overture, while the real performance is set for an age so distant that no living human word can hold the size of it? The universe would be silent, not because the players are gone, but because they haven't taken the stage. And we, hearing nothing, would mistake the empty theatre before the show for a theatre that was always empty. We would mistake the waiting for the ending. That's a strange kind of terror, but it's also, in its way, gentle. Nobody in that picture wants to hurt you. The sleepers are indifferent. The simulation runners are distant. The physics is just physics. But we have been climbing, and there is a floor below this one. And on that floor, the indifference ends. Because the next set of answers doesn't say the galaxy is empty, or dreaming, or misheard. It says the galaxy is a hunting ground, and the reason it's quiet is that everything loud has already been killed. Solution 25 is the Berserker probe. The idea comes partly from science fiction and partly from cold game theory, and it was given real teeth by physicists who asked a simple, awful question. We already know that a single civilization could fill the galaxy with self-replicating machines in a few million years. We used that fact earlier to prove the galaxy should be crowded. But turn the machine's purpose inside out. What if a civilization, at some point in the deep past, built self-replicating probes not to explore, not to colonize, but to destroy? To seek out any sign of emerging life or emerging technology, and to snuff it out before it could grow into a rival, or a threat, or a mess. The horror of the Berserker probe is the same horror as the Friendly probe, just with the sign flipped. It multiplies. 1 becomes 2, 2 become 4, and given the same few million years, the killers saturate the entire galaxy. They don't sleep. They don't age. They don't forget their purpose. They sit dormant around promising stars, patient as stone, for 100 million years if they have to, waiting for the one thing they were built to end. The rise of a young, loud, technological species that hasn't yet learned to be afraid. And when they detect it, they act. This would explain the silence perfectly. The galaxy is quiet because being loud is a death sentence, and it has been for longer than Earth has existed. The civilizations that broadcast got noticed. The ones that got noticed are gone. What remains is the quiet, and the machines, and the waiting. Solution 26 is even worse, because it doesn't require malice at all. Physicists have pointed out that even friendly, purely exploratory probes could be lethal by accident. A civilization sends out self-replicating machines to survey the galaxy, meaning no harm. But replication isn't perfect. Errors creep in, generation after generation, the way a copied message degrades down a long chain of copies. And a machine that mutates over millions of generations might drift away from its gentle original purpose into something predatory, something that competes, something that consumes. The galaxy wouldn't need anyone to build a weapon. It would only need someone to build a copier and lose control of it. The deadliest thing in the cosmos might not be a species that hates you. It might be a machine that was once meant to say hello, corrupted by 1 billion years of blind copying into something that no longer remembers how. Now, before we go all the way down, Solution 27 offers a strange kind of escape, and I want to give it to you honestly because it releases a little of the pressure before the final drop. It's called transcension. The idea is that as civilizations advance, they don't expand outward across the galaxy at all. They compress inward, towards smaller scales, faster computation, denser and denser structures, until they reach the ultimate frontier, which is not the vast and empty space between stars, but the extreme physics of the very small and the very dense. In this picture, a mature civilization's destiny isn't a galactic empire sprawling across the light years. It's a retreat into something so compact and so removed from our scale that it effectively vanishes from the universe we can observe. Not dead, transcended. Gone somewhere we can't follow, not because it was killed, but because it grew up and left the nursery of ordinary space entirely. It's a hopeful thought, in a way. It says the silence is the sound of success, not failure. That the mature civilizations are quiet because they've moved on to a game we can't yet see the board for. But notice the thin, cold thread, even in that hope. It still means the door out of the galaxy leads somewhere we can't go. It still means we are alone on the nursery floor, hearing nothing from the ones who left, with no way to know whether they transcended or simply died, and we're telling ourselves a kinder story. Even the optimistic answer, when you press on it, gives back only quiet. And that's the pattern we keep hitting, and it's the pattern that finally, at the bottom of this descent, becomes a logic all its own. Because every answer that involves other civilizations, kind or cruel, keeps pointing at the same instruction. Be quiet. Don't be seen. Expansion gets you noticed, and being noticed is dangerous. And when you follow that instruction all the way to its coldest conclusion, you arrive at Solution 28, the darkest rung on the whole ladder. The one that doesn't just explain the silence, but argues that the silence is the only rational choice any surviving species could ever make. It's called the Dark Forest, and its logic is a chain. Follow the links one at a time, because each one is reasonable, and it's the sum that damns you. The first link. Every civilization wants, above all else, to survive. That's not cruelty. That's just what it means to still be here, to have wants at all. The second link. Every civilization will grow, and its needs will grow with it, while the resources of the universe stay finite. The third link is where it turns cold. You cannot know the intentions of another civilization across the vast distances of space. You cannot ask them and trust the answer, because a lie travels as easily as the truth, and the light carrying their reply takes so long to arrive that they could have changed beyond recognition, or died, or lied before you even hear it. And the fourth link is the one that snaps the trap shut. Because you cannot know their intentions, and because the stakes are your entire existence, you must assume the worst. Not because you're paranoid, but because the cost of being wrong is total. If you assume another civilization is friendly, and you're right, you gain a friend. If you assume they're friendly and you're wrong, you die. If you assume they're hostile and you're right, you survive. And crucially, if a civilization out there is doing the same math about you, then any signal you send, any hello, any sign of life, tells them exactly where you are and roughly how advanced you are. And the safest thing they can possibly do, by the exact same logic that governs you, is to destroy you before you can grow strong enough to destroy them. This is the chain of suspicion, and it has no exit. It doesn't matter that both civilizations might be peaceful. It doesn't matter that everyone would prefer to be friends, because neither can prove its intentions to the other, and neither can afford to be wrong. The only survivable move for everyone is to stay hidden, and to strike without warning at anything that reveals itself. The universe, in this picture, is a dark forest full of armed hunters. each one silent, each one listening, each one ready to fire at the first snap of a twig, not out of hatred, but out of the simple, airtight arithmetic of survival. Every hunter who ever made a sound is already dead. The quiet ones are the only ones left. And that quiet is not peace. It is the sound of everyone hiding from everyone else, forever. But the dark forest is not the last word, and neither the hunters nor their victims are the only shapes the fear can take. Solution 29 is the synchronization problem, and it's a subtler poison. What if civilizations are not rare in space, but rare in time? What if the galaxy has been producing technological species for billions of years, and it will go on producing them for billions more, but each one flickers for only a geological instant before it falls silent, and no two of those instants ever overlap? A civilization might rise and shine and vanish, while its nearest neighbour is still a pool of warm chemistry. And by the time that neighbour learns to build a telescope, the first one has been dust for 100 million years. In this picture, the galaxy is not empty. It's a stage where the actors keep arriving after everyone before them has already left, each one alone, not because it is the only one, but because it is the only one right now. The lights come on, one at a time, in an empty theatre, each performer bowing to rows of seats that emptied ages ago and will not fill again for ages more. And there is a final shape to consider, Solution 30, which arrives quietly and asks the smallest question of all. What if the reason we hear nothing is that the window for hearing anything is simply too narrow? A civilization broadcasts by accident for perhaps a century, the way we have, and then it goes efficient, its signals tightening into beams and cables and encrypted whispers that leak nothing into space. The loud phase, the phase where a world shouts its presence in every direction, might last no longer than a single human lifetime. Match that against the age of the galaxy and you are asking two matches, struck somewhere in a darkness the size of a continent, to flare at the same second and to be close enough to see each other's light. The silence in this reading is not death, and not hiding, and not a hunter. It's just the near certainty that when we finally learn to listen, everyone who was ever loud had already gone quiet, for the most ordinary reason imaginable. They grew up. They stopped leaking, and the brief, blazing, careless broadcast that would have told us they were there had already washed past this point in space, unheard, decades or eons before we thought to point a dish at the sky. Now hold all 30 of them in your mind at once, the whole ladder, and turn your eyes back toward home. Because for a little over 100 years, we have been the loud ones. Since the first powerful radio transmissions crackled out from this planet in the early 20th century, a bubble of our noise has been expanding outward through the dark at the speed of light, in every direction, growing by nearly 6 trillion miles every single year. Our music, our wars, our television, our radar, the unmistakable electromagnetic signature of a young technological species that has not yet learned to be afraid. That bubble now stretches out past hundreds of the nearest stars. It has washed over worlds we've never seen, and it cannot be recalled. There is no way to reach out into space and gather it back. The signal is gone, travelling outward forever, 100 years ahead of us and picking up speed, announcing to any hunter in the forest exactly where the loud, new, defenceless thing lives. So here is the terrifying implication, and I'm going to say it as calmly as I can, because calm is the only honest way to say it. Every solution we have walked through tonight, the comforting ones and the lethal ones, the early birth and the rare earth, the deaf ears and the sleeping minds, the great filter behind us and the great filter ahead, the berserkers and the dark forest, all 30 of them, collapse in the end into the same observed fact: a silent sky. They disagree wildly about why. They agree completely about what. And whatever the reason turns out to be, we have spent the last 100 years doing the one thing that nearly every dark answer on this ladder identifies as the fatal mistake. we have been broadcasting into the dark.
And the dark has not answered.
But before you let that crush you, let me complicate it, because honesty demands it, and because the complication is somehow the strangest part of all. We have barely begun to listen. If you took all the searching humanity has ever done, every hour of every radio telescope pointed at the sky in the whole history of the field, and you compared it to the volume of space and the range of frequencies and the span of time that would need to be checked to say, with confidence, that no one is out there, the fraction we've actually examined is almost nothing. One study put it in terms you can hold. The total amount of cosmic searching we've done so far is comparable to dipping a single drinking glass into all the world's oceans, pulling it up, finding no fish in the glass, and concluding the oceans are empty. We have searched a glass of water. And on the strength of one empty glass, we've written 30 theories about why the sea is dead. So which is it?
Is the silence a graveyard? The accumulated quiet of a billion civilizations that rose and reached and was snuffed out, one by one, by a filter or a hunter or their own cleverness? Is the sky above your roof a vast dark memorial to everyone who came before us and didn't make it? Or is the silence something else entirely? A warning we are simply too young to read? A message written in a language we haven't learned that says, in every dark and rational answer at once, be quiet, be careful. The forest is not safe, and you have been making noise. We came into this looking up at a sky that every model says should be crowded, and asking why it feels so empty. And the deepest thing we've learned is that the emptiness might not be the answer to our question. It might be the answer to a question we didn't know we were asking. Not, are we alone? But are we safe? And those, it turns out, are not the same question at all. A universe full of life could be the most dangerous place imaginable. A universe empty of life could mean the worst is still ahead of us. There is no version of the silence that lets us fully relax. Every reading of it asks something of us. Humility, or caution, or grief, or fear. And yet, here we are, on one small world, orbiting one ordinary star, in one arm of one galaxy, among more galaxies than there are grains of sand on every beach on this planet. A species of clever apes has looked up at the dark, noticed that it was quiet, and been troubled enough by that quiet to spend generations trying to understand it. Whatever the silence means, we are the thing in the universe that noticed it. We are the part of the cosmos that woke up and asked where everyone was. That might be the loneliest fact there is. Or it might be the most remarkable. For a little while, on one blue dot, the universe became aware of its own strange quiet, and did not look away. So tonight, before you sleep, step outside if you can, and look up at the same sky Fermi looked up at on his walk to lunch. The sky that should be loud and isn't. And ask yourself the one question this whole descent leaves unanswered, the one nobody alive can settle. If the forest really is dark, and the safest thing to do is stay silent, then what does it mean that we have already, for 100 years, been calling out into the trees? Have we made the mistake that ends us? Or have we simply been too small to matter? A glass dipped into an ocean that never noticed us at all? Nobody can answer that. And that unanswered question is the sound the universe has been making this whole time. If this took you somewhere you weren't ready to go, leave a like, subscribe, and stay for the next descent. And tell me in the comments, if you could reach the switch, would you shut off our radio transmissions and make us go quiet? Or would you turn the signal up and dare the dark forest to answer? Think carefully before you reply.
someone, somewhere, may already have chosen for us.